So this is Wes Johnson. I am VP of Software for CirrusLink Solutions. I formerly worked for Archon Control Systems shortly after the invention of MQTT, which is somewhat important for the Eclipse Tahu project. Later on, Archon was actually acquired by EuroTech, where we open sourced the Eclipse Cura project. And shortly after I left, actually, Kapua was released as well. So internally at Eurotech, I worked heavily on both of those projects. And now we're going to release Eclipse Tahu. Chad, do you want to introduce yourself?
Sure. My name is Chad Kienle. I'm the principal software engineer here at CirrusLink. I've been working in IoT for about a decade now. I too worked at Eurotech on the same projects Wes just described, and now focused here at CirrusLink and getting this Eclipse Tahu project up and running in our Sparkplug specification. So I'll hand it back to Wes.
All right, so I'll go over the basics here. So as I mentioned, this is somewhat MQTT related. I should also mention Arlen Nipper is the president and CTO of CirrusLink, and he is also the co-inventor of MQTT along with Andy Stanford Clark. So obviously all of these projects are a little bit MQTT centric, both including Kura, Kapua, and Tahu. All right, so let's start off with what is SCADA. This is the Eclipse IoT working group, so I don't think I need to explain too much here. This is the Wikipedia definition of SCADA. At CirrusLink, we focus primarily, and not necessarily by choice, but most of the projects that we've worked on with regard to SCADA are oil and gas pipeline control systems. And also, much more recently, factory floor automation. And it's kind of interesting how both of those are tied together. So a lot of people don't know that MQTT was actually originally invented for SCADA specifically. But as the SCADA systems within factory floors become much more bandwidth intensive because of the amount of data being collected, it's really put limits on the networks that are there. Just as it did previously in the original invention of MQTT being over VSAT networks. So optimizing network traffic by using non-polling protocols such as MQTT has actually become pretty important. So this is also mostly from Wikipedia, so the generations of SCADA. So the term SCADA has changed or been changed over time. So there is the third generation, which is generally viewed as what's deployed today. So it's the networked form of SCADA. And we're moving towards that fourth generation, which is the IIoT. And so the differences there are moving from polling to non-polling protocols, but most importantly and conceptually improving security, interoperability, integration, and reducing complexity and cost. So with that, this is sort of what we see in today's SCADA system. So you have your operational data over here on the right. There's a SCADA host that's doing some polling and aggregating all of that data. And then typically its primary function is to act as the supervisor and also typically to push some data into a historian. And then over time, what's happened is lots of different IT components have come in and said, hey, we need that data for this. And so that could be an ERP system or a mobile app or maybe a company-wide goal to do some improvement within the operations. What's interesting is from experience of us working with both sides of the IT and the OT groups within companies, is generally the OT group is there, and they're pretty happy with the way things are working, and most importantly, they don't want this to be touched. As IT has more and more demands upon the system, they ultimately get told that they can't have any more data because the system is so brittle at this point in terms of how data is being extracted from it versus what it was originally intended to do. So with that, if we look at some ways of how we'd go about solving that, this is actually from the Eclipse IoT Developer Survey from this year. And you can see that MQTT is now one of the more popular messaging protocols for IoT solutions. And we've watched this sort of steadily increase over the year. So we're hoping that we're on the right track. And if we look at that type of system, how would it look if we actually built it that way instead of using a single application to a device model? And so this is what we have in how we're designing these systems today. So we have an MQTT server infrastructure. One of the things that we've done here at SiriusLink, and actually we've pushed this into what is now the Sparkplug specification, which is part of the basis of Eclipse Tahu. And that is that we don't just use single MQTT servers. And so one of the goals of many commercial MQTT servers that exist, and also the notion of MQTT bridging, is that they're sort of horizontally scalable and you can connect as many clients as you want. In the original deployment of MQTT for Phillips 66, which is who it was designed for, so it was specifically for oil and gas pipeline monitoring and control. It was actually 6 different MQTT servers that were distributed within various areas. So the pipelines that were being monitored were mostly through South Central United States. So they're tornado prone, there are thunderstorms that affect VSAT connections. So they knew that these devices could be affected by weather and other external conditions. And so what happened was each of the devices that were the MQTT connections actually had the ability to connect to multiple different MQTT servers, and they did so in a round-robin fashion. So we actually use the same model here, and we can do the same things both for scalability and for redundancy in the systems that we deploy today. But if you do manage to get your MQTT devices on the right publishing into this MQTT server architecture, because MQTT is pub sub, then connecting additional applications and consumers of data is much easier, unlike the previous model. So what is Tahu? So Tahu is Maori, to ignite, combust, light, or set on fire. So this is derived from what we were already calling Sparkplug. So it's a specification that we've already released. And really the name Sparkplug in some ways revolved around the notion of creating a spark for MQTT, and most specifically around its original intent. So MQTT has a lot of advantages in the fact that the topics are not defined and the fact that the payload isn't defined, but also that means that clients can't really communicate with each other without a definition. So in large part, Sparkplug solves these problems by creating a common definition that allows those clients to communicate with each other. And in doing so, it specifies the topic namespace, the payload encoding mechanism, and also, importantly, state management, which is something that I think often gets lost in MQTT environments. Largely today, I think MQTT is often used for ingest only. The fact that it is bidirectional and pub sub is often not taken advantage of. So the Sparkplug specification is part of what we're contributing, as well as the Tahu source code. So we already have a public GitHub repository, and so this would be part of the Tahu project, which includes client library implementations as well as some examples. So the Sparkplug specification itself defines the MQTT topic namespace. So what we did is constructed a notion of both groups, edge nodes, and devices. So typically an edge node would represent an edge gateway out in the field. and the devices would represent things like RTUs or PLCs that were either on the factory floor or on the oil pipeline. By defining this namespace, really one of the main things we were looking to do was to allow for individual nodes to be addressed within the system. And so they could subscribe on specific topics and know when messages were destined for them. And likewise, when a backend system was listening for messages, it could know what message or what device those messages came from. In addition, we've specified some verbs so we know what direction those messages are going, either to or from. So are the command messages that are destined for a device, or are they data messages that are originating from a device? We also defined the payload definition, so we utilized Google protobufs for this. We actually started with the Cura protobuf payload definition, but pretty quickly determined that for SCADA applications that wasn't very sufficient. There was far too much metadata that was required within the context of SCADA environments, and certainly for what fourth generation SCADA environments would be. So for example, when a tag gets provisioned on an edge device, that would include typically a key value pair and a data type, but we also wanted to include things like engineering units and scaling factors that were actually specified at the edge, which became this sort of single source of truth. Big problem with third generation SCADA systems is that tags need to be configured across the system. And so you might go into an edge device and say that these are my engineering units and these are my scaling factor, and maybe even additional metadata associated with that tag. But then when you go to the SCADA host, you have to enter in all of that same information again. So we wanted that to originate from that source and be able to be pushed up and pushed through the system. Then also defining state management. So really what this is utilizing the fact that MQTT is stateful. So MQTT is based on TCP. And with that, when you establish a connection, you can then publish information based on changes rather than by polling, or even based on periodic publishing of messages. So what we did is we utilized the notion of a birth certificate, which is not within the MQTT specification. And in that birth certificate, we always publish all of the known tags, all of their values, and all of their metadata, which then tells the backend that this device has established a stateful connection. And from that point going forward, until the MQTT session is lost, we don't need to push any new data unless that data has changed at the edge. So what we found, for example, in factory floor automation scenarios, is you still have PLCs that are legacy devices, or typically called brownfield devices, that still need to be polled. But you can utilize local edge gateways with what are effectively small OPC servers that are acting as polling engines. And they can poll for this data locally at very high frequencies, but then actually only publish those change messages based on when data changes. And what happens ultimately is in even high-speed factory floor networks, you can get significantly reduce your bandwidth requirements just because you're doing polling locally rather than across the network as a whole. All right, so the source code itself, like I said, this is already available at this GitHub repository, but this is pretty much exactly what we'll be contributing. It does need to be refactored and everything as part of the process, but that'll happen as well. So the implementations of both the client libraries and the examples are currently in C, Java, JavaScript, Python, and we have Node-RED examples as well. We actually do have some partner companies that are working on implementations in structured text and also in C#. So we're hoping that we can get those wrapped up in what we release at some point as well. So as far as companies that we have involved, so one of the things that sort of blew us away is when we first started talking to both partner companies, hardware companies, and other software vendors, we found that there was a lot of interest in this. So obviously Sparkplug is not a standard in the classical sense. But people liked the notion that there was a definition and that they could use it and it would interoperate with other applications that were in the process of being made. So for example, Easy Automation took our C client library and they have now implemented Sparkplug on natively on one of their low-cost PLCs. So you don't even need an edge gateway in that scenario. OSIsoft is the maker of the Pi Historian, which is very commonly used, especially in the oil and gas industry, but for SCADA systems in general. They have a Sparkplug connector to be able to consume messages that are coming from them to be able to insert into their Pi Historian. Moxa is an edge gateway manufacturer. They have natively implemented Sparkplug on their edge gateways, which actually Chad will show in the demo that he's going to do shortly after this. So they have these I/O modules that are stackable, so you can put many of them together, and then it will natively push out Sparkplug messages from those I/O devices to an MQTT server. Redline, Opto22, Hilscher, Magnetrol, Advantech is also currently in the process of putting Sparkplug on a number of their different devices. So you can see that there are a lot of companies that are already actively involved in implementing Sparkplug on real-world devices. So these are additional companies that are actually in the process of developing or implementing Sparkplug onto their devices. So ABB, Emerson, and Omron, ABB and Emerson are both electronic flow meter companies, or that's part of their product portfolio. So for next generation EFM devices, these will be Sparkplug enabled. CirrusLink is actually in the process of working on some software to make some of the older models of these Sparkplug enabled currently. Omron also is implementing native Sparkplug on their PLCs currently, and also we're working with Cisco to release a product called Ignition Edge, which basically Sparkplug enables their Cisco 800 series routers, which should be available within the next few months here. So there's lots of existing activity around this, and we were starting to get some push from some of these companies to do something like officially open source Sparkplug, which we had already made it open. We had already released it under EPL on our GitHub site. But we thought that taking a step of formalizing this through the Eclipse Foundation made a lot of sense. In terms of collaboration opportunities, part of what pushed us to do this was that we really wanted a Sparkplug decoder for MQTT SPI. So some collaboration with Paho, I think makes sense. Also, we've previously talked with Eurotech about potentially creating a Sparkplug module that ran inside of Cura, so not to work with the interconnectivity of Kapua and Cura, but rather be a data provider to a third-party MQTT server in that scenario. NeoSCADA seems like a natural fit. Smart home seems like there could be some interesting things that could happen there. I think that there may be some interest in consumer smart home like devices implementing Sparkplug natively on theirs, just as we're seeing in the industrial market today. And then Unide 2, so my familiarity with it is pretty small, but it looks like there may be some overlaps and synergies there that may be interesting as well. So before I hand it off to Chad for a quick demo, are there any questions? And also there are some resources here. So the specification as it exists today, the existing GitHub repo, and then there's also a demo video link here that is, it covers much of what Chad's going to cover here in a minute.
Hi, this is Ian Craggs. I'm Tahu project lead. This looks great. So you mentioned it isn't a standard at the moment, but is standardization something that you have thought about?
It's something we've thought about, not a lot, but I think that as long as momentum is maintained for this project and as we see more companies adopt it, I think that that would be a natural progression for this.
Have you had any push from the companies involved for standardization?
Yes, it's certainly been brought up. I wouldn't say that that push has been hard yet, but okay. Yeah, it's been brought up for sure.
Have you been taking aware, or are you aware of the progress in MQTT v5? Because I thought the things that you were talking about, there seem to be some features in version 5 that you might be able to take advantage of. Obviously, from a point of view of implementation, that's a good way out because we're only just finishing the specification standardization of it. So,
right. So yeah, we certainly have been following that, and really many of the things that we found actually don't overlap. Okay. I think there are some features of v5 that we may utilize, but things like this sort of notion of state around a session and how that affects data traveling over that session during that time isn't addressed in v5, and that's really one of the specific goals of Sparkplug.
Okay, thanks.
Sure. Anything else before I hand it to Chad?
Yeah, hi, this is Kai from Bosch. I also do have a question. Is there any communication between devices or gateways intended over this mechanism? Or is it always just communication between a device or sensor and a backend application?
So we don't explicitly prevent that from happening or disallow that even from a specification standpoint. The concepts are really built around a host backend application, sort of in a traditional SCADA host type environment. But there's nothing that would prevent a device from doing that. Certainly, from a security perspective, there are things that you have to worry about there. So one of the things that we do is, so we have ACLs implemented on our commercial broker offerings. And typically a device is only allowed to publish or subscribe on its specific topics that it's allowed to. So, for example, a device couldn't spoof another device, and also another device couldn't send a command to another device. But if you wanted to allow that, you certainly could.
Okay, thank you.
Okay, anything else? All right, Chad.
Okay. Let me share my screen. Thanks, Wes. I think you need to stop sharing first.
All right, I'm stopped. You should have it now.
All right. See my screen?
Yep.
All right. Okay, so I'm going to show a little demonstration of how we leverage Sparkplug in our existing products and some of the features and how it can be deployed. What you're seeing here is a Ignition Gateway Web UI. So Ignition is a SCADA host application created by Inductive Automation. And we have this running in AWS in the cloud. And if I go over to configure and look, it's a modular application. And if we scroll down, this is a standard Ignition install, but we scroll down here and we can see that there are some CirrusLink solution modules. These are products that we make that plug into Ignition that provide MQTT connectivity, and more importantly, are built upon our Sparkplug specification. So one of these modules is MQTT distributor, which just provides a basic MQTT 311 compliant server. And more importantly, we have an MQTT engine module, which is a Sparkplug application, and it basically takes connections to different MQTT servers and subscribes to Sparkplug data flowing through them, and takes that Sparkplug data representing edge devices and edge controllers, and it converts those to tags within Ignition so that different dashboards and such can be created, and that data can be consumed in a centralized location on an Ignition gateway. We also have an MQTT transmission module, which does pretty much the opposite. It usually sits out on an edge controller or in an edge environment and takes OPC tag data, builds those up into Sparkplug messages, and then publishes those out to a MQTT server. And Engine would sit there on the other side of that and subscribe to that, and then pull all that data into a centralized gateway. So this is that centralized gateway, and when you install MQTT Engine, you can go over to configure it. If I click on this servers tab, we can see that it's got 3 different MQTT servers defined. I want to note that it's pretty irrelevant where these servers are located. We've got a couple in the cloud, and then one is that local MQTT distributor module that I showed you. But these can basically be anywhere. They just need to be a server out there that can act as a centralized hub for the infrastructure. So we've got 3 of them defined here. Right now I have MQTT Engine disabled, so it's not actually connected out and live with those servers, but we'll get to that in a second. I can launch Designer, and what Designer is it's an application that is used for designing HMI screens. So we get to see over here on the left, we get to see all the different tags that are in this Ignition gateway, and then you can design all sorts of interesting screens to display your data and interact with those tags. We have a MQTT Engine tag provider here, which is where MQTT Engine creates all the tags that represent all the Sparkplug data that flows in. And Sparkplug has a way of naming and identifying devices, edge devices, using group IDs, edge node IDs, and device IDs, and it takes those IDs and creates a tag structure under this edge nodes folder to represent all the devices that it receives data from. And since we know that well-formed tag structure, we can go ahead and create different dashboards to model that data without actually knowing what devices are out there before we even start consuming that data. So we've got a number of different screens built up to demonstrate the different infrastructure and all the devices we have out there. We have over 1,400 devices across various different hardware platforms. And what I'm going to do is I'm going to enable Engine, and then we're going to see how quickly 1,400 devices can populate in this Ignition gateway using our MQTT module, but specifically using Sparkplug. So all those devices are out there connected to the brokers, and if I go and enable Engine, save it, and go back here, we can wait a few seconds, and we should start seeing all the different devices identified by little green dots here populating within our gateway. All right, so there we are. In about 10 to 15 seconds, we identified 1,400 different devices. And It's over 700 different edge nodes. So if I refresh over here, we can look in that folder and we see all these different devices. We've got Avantec devices, Alexis Ready Gates, Ignition Edge devices, a Moxa 8100 Things Pro device connected to some PLCs, or not some, yeah, and various different devices set up in our lab and some set up elsewhere. But one thing here is this happened in about 15 seconds without knowing anything about any of these devices or what was actually live and connected. As Wes said, in a traditional SCADA infrastructure, these would have to be configured on both ends. They'd have to be configured on the edge and in whatever application was consuming them. But here we had probably hundreds of hours of work configuring all these different tags, and it all happened just instantly because of all these Sparkplug enabled devices describing themselves right when they heard that this application came connected to those brokers. And so it's a pretty cool disruptive thing to the industry that everybody's very excited about. So I can look at this Moxa device here, this 8100. It's connected over cellular. And I have a dashboard that represents it. So it's connected to these 5 IOLogic Modbus TCP IO modules. It's pulling them at 100 milliseconds. So we can look at these different registers, and so all these little widgets are tied to tags, so I can actually write to one of these relays. If I write to this relay right here, what happens is we get maybe
read-write mode.
Yeah, sorry, I have to enable read-write mode. Thanks, Wes. So what happens when I write to one of these, and I'll do it here in a second. Sparkplug or MQTT engine will send out a Sparkplug command for this specific data point. That command will go down to the edge device. The edge device will write to that PLC, and that data point will be updated, and then the edge device will respond with a data message, and that data message will get published back to engine, and then engine will update the tag itself. So if I click on this, we'll see that get updated on the edge and then get sent back to engine and updated here in engine. And out on the edge, that relay is actually tied to this digital input, so we got to see both of them change. Another thing we have set up is this relay 4. We have set up to an Ethernet switch right here that is, if we disable this, it would disable this Ethernet switch, and we'd see these 2 devices over here go offline. So if I click on that, what we see happen is these devices went offline, so the edge application actually published death certificates on these devices' behalf, and engine received those death certificates, staled all those tags since those devices were no longer connected, and we didn't know that we had good data from them. So all these tags are stale, and engine knows that until those devices come back online and publish their births, then they'll remain stale. One thing I can do over here is I can reset my throughput, the amount of bytes going through the system, and we can see that there's basically no bytes coming through from this edge node right now. But these PLCs are being pulled at 100 milliseconds. So since none of the data is changing over here, we aren't seeing any bandwidth being used, and that's a huge reduction and increase in efficiency and the overall infrastructure, in that it does only report by exception. So only when these different data points change, if I click on this, then we'll see some data come across. But when nothing's changing, then nothing actually needs to be flowing. And since we have a stateful session with these, we know that all these data points are good without having to pull them. And so I can turn this Ethernet switch back on. And And we'll see these devices pop back in after they publish their births. And then we'll see some more data flowing from them. So over here, we can go into another device. We have on an embedded Linux Raspberry Pi, we have Ignition Edge running. So Ignition Edge is like kind of a slimmed down ignition gateway that's meant to be placed on the edge, and it contains an OPC server as well as our MQTT transmission module. And so what transmission does is you basically put it on an edge device in Ignition and point it to some OPC data that you want, or any tags for that matter. And it will monitor those tags. It'll publish a birth representing them to a broker, and then it will capture any data changes and publish those as Sparkplug messages. So we have it connected, this Ignition Edge Raspberry Pi we have connected to a Click Modbus PLC, and I can actually pull up the designer. So this is the designer that's connected to the Ignition Edge instance running on that Raspberry Pi. And if I browse tags on it, we can see the tags over on the edge, and then over here we can see the tags on the centralized ignition gateway running MQTT engine. So a few things I'd like to point out here. So I can do some manual changing of some of these tags, and we'll see it reflected. I can turn on this pump control, and we see this pump control over here. I can also turn it on and off from the ignition side, and that'll send the command down to the device, which will update it and then send the data back to Ignition to confirm that the tag was changed. So I can do that, and then we see it change there. Let me make this smaller. Another thing is these tags have a lot of metadata associated with them. So for this case pressure up here, if I want to look at all the different properties associated with it, we can see that the engineering unit is PSI, and over here, this case pressure gets an engineering unit PSI, and that was configured at the edge. So the edge is the single source of truth for all these tags. So as things change, if I wanted to change that PSI to something else, custom units, I could change that, go down. Since I made a configuration change over here, just refresh this. And over here on this side, we'd see the engineering unit changed to whatever I changed it to. So we can do any kind of configuration at the edge, and it's just immediately reflected on the centralized ignition system over here. So, and that's due to how Sparkplug allows a wide variety of different metrics to be associated with tags and sensors.
But SCADA, I think at this point we probably want to open it for questions.
Yep. That was the last thing I was going to show. So.
All right, super. Are there any questions following the demo? All right, so maybe to wrap things up, I think this is part of the proposal. I don't remember if you guys covered it in the slides. What are the next steps for the project, like timeline-wise? When do you expect the code contribution to hit the Eclipse repos and things like that?
So we're hoping within the next couple of months. So there's not a lot that we have to do. The source code already exists. There's a bit of refactoring that we have to do. So really from our perspective, there isn't a whole lot of work. It's just going through the formal steps to get this done. So basically as soon as we can.
All right. So as always, for people on the call, if you feel like this is something you would like to be more involved with, or like just a project you have you're generally interested in, feel free to let Chad and Wes know and ask to be listed as interested parties. And yeah, I mean, it will be interesting to see how this project evolves over time. Like what I especially like is that there seems to be lots of possible collaboration opportunities with Kura, Kapua, and Unite, etc., etc. I think Vorto might also be interesting. Well, pretty much all our projects. So yeah, thanks again, Chad and Wes. And yeah, I guess next action item for everyone is to use the project proposal page to engage and discuss the project.